The next property of sound we're going to look at is amplitude, which is the kind of extent of the wave, how wide it's moving, or actually how much the air compresses and rarefies as that waveform moves or propagates through the air. Now, there are many types of waves, and one of the tough things is that we tend to think of a wave like a wave on a pond, which is this flat surface with vibrations on top of it. And the truth is, wave in the air moves a little bit of a different way. Air on a pond, the direction of the vibration is perpendicular, or kind of at a right angle to the direction of propagation. But sound in air, the direction of the vibration is parallel, the same direction as the direction of propagation. I'm going to use this spring to kind of demonstrate what I mean by that. So if we look at a wave on a pond or sound on a guitar string, we'll see a wave kind of like this, where it's propagating this way, but we see the wave is moving that way. Now in the air, we have the air compressing and rarefying, and we call it a longitudinal wave because the direction of vibration is parallel to the direction of propagation. So if I was to push on one end of the spring here, we see that the wave moves down and back through the spring. Now, the extent of that, the amount of compression, is the amplitude. If we thought of amplitude in a transverse wave, it'd be the amount that I swing it back and forth. So that would have a high amplitude, and that would have a low amplitude. If I think of a longitudinal wave, if I push gently, we get a slight movement across the spring, and that's a low amplitude. If I push very hard on this, we get a large wave, and that's a high amplitude. So amplitude is the extent of compression and rarefaction of the air. Compression is the amount that the air is getting more dense as the wave moves by, and rarefaction is the way that the air is getting less dense as the wave moves by. The extent of that is our amplitude. Now, perceptually, we hear that as being louder or quieter. The higher the amplitude, the louder it is. Now, when we look at diagrams of waveforms, though, we never see, how would you diagram the longitudinal wave? It's very difficult. So we diagram it as if it's transverse. But we need to know, when we're thinking about air, that it is this longitudinal compression and rarefaction that's moving in the same direction as the propagation. Amplitude is measured in decibels, and there are numerous places in our signal flow where we do measure amplitude. We measure it out in the air, and in that instance we use decibels of sound pressure level, or dBSPL. Now, the thing you have to know about decibels is it's a relative measure. There's no definite set point where 0 is, and it gets used differently in a variety of contexts. So in the air, we use dBSPL, and the SPL portion of it is actually setting where 0 is. And dBSPL is related to the threshold of hearing, or the quietest thing we can possibly hear in the air. Once we get into the digital domain and into the computer, we measure amplitude with dBFS, or full scale. And that then is related to the loudest thing that can be represented in numbers within the computer. And we find a kind of variation in the way the numbers work. If we're thinking about the real world out here, we measure dBSPL, it's going to be from 0 being the quietest thing, and it just gets louder and louder and louder until it gets to the kind of threshold of pain, or the loudest thing we can perceive with comfortably. When we're in the computer, we measure dBFS, and in that case, we have 0 as the loudest possible thing that can be represented in the computer, and it goes negative from there. So you're much more likely to see negative dB in the computer, but positive dB when you're talking about sound in the air. Now, this is important just because a lot of times you leave off the extension. Everyone just says dB, but you need to recognize every time you hear someone talking about amplitude and talking about decibels, you need to know the context. You need to realize, are they talking about dBSPL in the air, or are they talking about dBFS, full scale, inside the computer? People will tend to use the terms amplitude and loudness interchangeably, and we're going to find that as we go through these 6 weeks that we're going to get finer and finer definitions for some common words. And in fact, amplitude and loudness are different things. Amplitude is something measurable by a computer, and loudness is our perception of that. And actually, our perception of amplitude is a very complex thing and includes many other factors like mostly duration, how long has this thing been loud for, and also frequency. We hear amplitudes different in the lows and the highs. So it's important in our own conversation, in our forums, and in our discussions with each other that we start being really particular about, are we talking about amplitude, which is a measurable thing in the real world and in the computer, or are we talking about loudness, which is the human perception of amplitude, which is related to things like duration and frequency. When producing music, amplitude becomes a primary concern. Our functions of mixing is largely based on controlling the amplitude of our many tracks and making them relative to each other in a pleasing way. The idea of panning is controlling the level between the two speakers. And we have a number of plugins that are our dynamic plugins, which are going to be controlling the amplitude of our signal over time. The dynamic plugins are going to be your expanders, gates, compressors, and limiters. Now, amplitude also comes into a great extent when looking at gear. So if you're buying a microphone, you'll see something called the dynamic range of the microphone. And the dynamic range of a microphone is the decibels in which it will reproduce the sound properly. And when you talk about dynamic range, and this is another one of those words that's going to be used different ways in different contexts, but when you're talking about dynamic range in a piece of gear, it's the range and levels between the noise floor, or the quietest, it's just going to be a hiss that the device is putting out, and the distortion, when you get so loud that it just can't reproduce it, and it gives you an ugly crackling or upper harmonics are added to the signal. So your dynamic range is your distance from the quietest things that can be reduced clearly above the noise, so your noise floor, to your distortion is going to be your dynamic range. Every piece of gear has a specific dynamic range. Our own ears have a dynamic range. And we also use the term dynamic range when talking about a piece of music. You can say the dynamic range of a piece of music is the range from its quietest section to its loudest. So we see that this idea of amplitude is going to be of primary concern throughout the music production process, and it's something to take very great care with. When you're setting levels for a microphone, when you're mixing, when you're setting your output levels, it's something always to be aware of. And this is, again, a big topic. The idea of decibels, there's so much more to think about there. So this is something I would really love you to take to the forums and even look for outside resources about this stuff. Things to look up would be logarithms, dynamic range, decibels, equal loudness contours, the Fletcher-Munson curves, and dynamic range.